All right, so now we're going to divide this polynomial. That's what we're going to do. Anytime the degree of the numerator is equal to or greater than the degree of the denominator, look for that even before you look for u substitution. It's the very first thing you should look for in rational expressions. Is the numerator of equal or higher degree than the denominator? If it is, then you must start by doing polynomial division. All right, so how do I do this again? Oh yeah, I put like plus 0, x squared plus 0, x plus 0. There are other ways to organize this. This is sort of the standard way. I like to say I need to match this to x cubed, so I need to multiply by 2x. So I like to keep all my like terms in a column. So I'm going to put the 2x over the 0x. You don't have to do that. I'm going to get 2x cubed, and it's going to be minus 2x, so I'm going to put the minus 2x over here. See all my like terms in a column. Subtractee, that's 0. Remember, 0 minus negative 2x is positive 2x, and I have plus 0 to bring down. Okay, so basically there's nothing left to bring down, and what we have left here is my remainder. X squared minus 1 cannot go into 2x, so I put that remainder like this, plus 2x over x squared minus 1. If this was negative 2x, I'd say minus 2x. All right, so the first thing to do is to use this polynomial division to rewrite the integral. So I've restarted here, so I'm going to start again with the integral of 2x cubed over x squared minus 1 dx is equal to the integral of 2x plus 2x over x squared minus 1 dx. Now, doing this part is going to require my rational function techniques, but this one doesn't. It's just a polynomial. So let's go ahead and do this one. It's just x squared, right? I did that antiderivative, but I'm not doing this antiderivative. So, notationally pay attention to what we're doing. I did this integral, so it's no longer, I did this antiderivative, no longer an antiderivative sign. This antiderivative I have not done. I haven't done anything with it, so it still has the integral sign. Right? But this one I've done. I have not put the plus c yet because I still have an integral, so the plus c can be thought of as being tied up in this unfinished integral. We put the plus c when the last integral is done. All right, so then on this one, just say, okay, what's my technique going to be on this one? Well, first thing I should look for in this is, can I do u substitution? Indeed, I can, because u equals x squared minus 1. So you always start with denominator for u. So du is equal to 2x dx, which happens to be exactly what I have up there. So that means that I have x squared plus the integral of du over u. And I still haven't done the antiderivative, so I still don't have a plus c. So now I can call this ln of absolute value of u. Now I put the plus c because I've done all the antiderivatives, but I do need to sub back in my u, which was x squared minus 1. So plus ln of absolute value of x squared minus 1 plus c bejoing. That's number 22. All right, let's see what else we're going to do. We're going to go to Rogowski. We have our good old friend Rogowski. This one's got some tricks to it, some sneaky tricks. So I'll probably start a whole new video for it. So I'll let you guys start thinking about it first. This is from Rogowski, page 434. You're going to see that I'm going to assign you number 5, 6, and 7. So I'm going to save the hard one for myself, which is number 8. So number 8 says the integral of x cubed plus 1 over x squared plus 1 dx. So you should see if you can do at least the first step of this. The first step is we're going to notice that the degree of the numerator is higher than the degree of the denominator. We would do this also if the degree of the numerator is equal. So if I had x squared, well, if I had like x squared plus 5 over x squared plus 1, I would start by doing I mean, that's an interesting problem. Maybe we should do that one. I would start by doing long division. This one, go ahead and start the long division, but I will just tell you that what comes out of it is some other surprising, tricky things. So you could, if you want, see how far you can get with it, but I'm expecting it to not be obvious. So, but at least see if you can do the division.